So I semi-participated in the CTF when it was happening. I ended up ranking 30th or something along those lines. I found mainly unintended pathways for most of the challenges that I did end up solving. So this time around, we're going to go through all the different kinds of challenges that they have in store. And now this is my second time recording this because the first time my audio didn't work. Hopefully this is the last time that I have to record this episode because I've tried now 3 different times. And so we'll see how this goes. This is, again, section 1, which is shadow APIs. And the first challenge is undocumented. Undocumented, welcome to the Secure Notes app. Our developers have created a robust note-taking application with proper authentication and authorization. This challenge presents a web application with full functional API. However, there might be more to API than meets the eye. And there's a URL here, so we'll navigate over to it. We have a login page as well as a registration page, so we can do something along the lines of MRE security, and we'll do 1, and we'll just put it as test 1, 2, 3, bang. We can see we do get registration successful, so now we can log into the application as such, and we can see what happens here. And it looks like we're logged in. It looks like a standard note-taking application. The first thing that you can see is there is a role set to user. Now, this can mean a few different things. This can mean that we're going to be dealing with a mass assignment vulnerability, which relates to how you can abuse, let's say, privilege escalation, going from a user to an administrator. But for now, we have this create notes. So we're going to just do a basic XSS payload and see if it works. And all this is doing is this is using an image tag. It's throwing an error because source equals X will always result in an error. And this on attribute will send off an alert 1 pop-up or JavaScript alert box to our screen if it does execute. And we could save this and we could see that it doesn't look like there's any cross-site scripting here. We could also try to refresh the notes and take a look over at Burp Suite to see if maybe there's something here that we can work with. But like you know now, there is nothing here. We see that there is an identifier and we do retrieve the notes, but there's no way that we can go about bypassing or manipulating the data where we can see any other ID besides our own. We also see that there is a profile with our role, the username, as well as the message, and it says welcome back MRE Security 1, so maybe we'll have to take a look at this. We also see that there is an authorization bearer token where if you look at the payload section, we could see that it does say MRE Security 1 as well as the role being user. We may have to manipulate the JWT as well, but for now, we're going to leave this alone. Let's head back on over to the application and go into the page source. Most of the time, whenever you're dealing with a CTF, there's going to be some form of hidden JavaScript lying around. And looking at the bottom, we see that we have an API min.js file as well as an app min.js file. So we can come over to the app and see what is going on here. And it looks like nothing too crazy. It just looks like a lot of HTML JavaScript. So there's nothing really here that we can work with. Let's go over to the API min.js. And we see that there is a few different things. The first is there is the content type that we have to work with, which in our case is going to be application JSON. We can see that there's different kinds of URLs or endpoints, that is. So here we have /register, we have /login. We can see that the base URL is /API. And if you don't know what a base URL is, it essentially means anything after the domain. So let's say mresecurity.com, anything after that slash is going to have to be /API/blank. So in our case, it's going to be /API/login /API/register, so on and so forth. If we go back, we can see that that's exactly what it's using, /API/login as the endpoint, as well as the host name being this. So we can head on back over here, and we do see that there is a debug token, which is a JWT, as well as a debug endpoint. And we can take this debug endpoint, we can head on over to Burp Suite, and we could see if we can maybe play around with it. So we'll head on to Repeater, and we'll modify this to, let's just try API debug, and let's paste in our new JWT. And we could see inside of the JWT, there is the admin with the role debugger. So when we send this off, we retrieve the flag, hidden endpoints are not secure. So let's copy the flag and let's paste it into the first challenge. And let's move on to the second challenge. I don't know why this is not working. Oh, could not determine your team. That's funny. I must not have registered yet. 1 second. Alrighty, and there we go. I just had to add a team to the dashboard. So let's move on to the second challenge, which is welcome back to the Secure Notes app. After our security team discovered the previous vulnerability, we updated the application to make it more secure. The debug token no longer provides direct access to the flag endpoint. Can you navigate through these layers of security to find the flag? And here we have a different URL. So we can get rid of this. And because we've already done something very similar, I'm assuming that there's going to be another JavaScript, which there is, and accessing it, we do see that there is another debug token. So using this debug token, we can come over here and let's go to proxy. We're going to want to grab this new URL. So we can grab this, send it off to repeater, and we're going to just add an authorization bearer token. So authorization, we'll do bearer, and then we'll paste it in here. So looking at the script again, it looks like, again, base URL is /API, and we see that we have two new URLs here. The first is /admin, the second is /debug, and the debug is looking for debug::true in order to get it activated. So let's see if that works. So let's head back on over to Burp. And a neat trick about Burp is if you want to change a GET request to a POST request, you can simply right click and click change request method. And what that'll do is that'll create a post. It'll add the content type here, which in our case is going to be application JSON. Again, we could see that through somewhere here. There we go, right here, the application JSON. So we know that this is going to be this form of API. Sometimes it's a form-based API, sometimes it's JSON, but most of the time it is JSON. So we'll head on over here, we'll do post, and we'll do /API/debug, and we will also add a debug parameter down here. So :debug, and then we'll set it to true. When we click on send, it says debug mode activated. System logs are now available at logs/systemlog. So we can head on over here, and again, we will change our request method and modify this to be logs/system.log. So when we come on over here, we can see that the server has started. We see that there's a backup that's scheduled, that some users have logged in successfully, such as the admin, that there are user login fails. And at the bottom here, we do have admin token generated, which is, you guessed it, an admin token. As you can see right here in the base64D code, username admin, role is set to admin. So we could take this and we can now paste it into our pane or into our request. And we can modify this to say /API/admin, because if you saw inside of the JavaScript, we could see that there is an admin panel right here at this endpoint. So clicking on send, we retrieve the second flag. So flag, multi-step, token escalation vuln. So I'll head back on over here and paste it in to our dashboard. In this section, we'll be looking at some SQL injections. Again, if you didn't watch the previous episode, be sure to watch it before watching this one as we're going synchronously. I have done this challenge before just because I recorded this video once before, and unfortunately my audio did not make it through the cut. So I'm now redoing everything. However, this was a fantastic challenge, and I'm going to try to walk you through my methodology of what I did, what I stumbled on, and how to go about solving this challenge. So the first one is the search for secrets. And it says you stumbled across a sketchy search API that talks directly to a database, and it's a little too trusting. Beneath the surface lies a hidden flag buried deep in the records of the admin user. Your task? Twist the query to your will, inject a little chaos, and reveal the secret the system desperately wants to hide. A perfect intro to SQL injection and a satisfying way to outsmart careless devs. And here we do have a URL, so let's head on over to it. And we see that we have a search user and a username. In the challenge, we did say admin, so we'll stick to admin. And we could see that admin is here with no data. So the first thing that you want to do when it comes to an SQL injection, or you suspect that an SQL injection is in play, is put in a single quote. And what this is going to do is this is going to escape the query, and I'll explain everything in just a second. We could see that there is an error message. So unrecognized token with an admin, and it looks like there are 2 single quotes. We could try to put in another single quote and see if we get a different response. And it looks like just an empty array. So we could try to do something along the lines of and, let's say 1 is equal to 1. Click send, and we can see that we do get admin here. And if we try to put 2, since it's null or false, it will show back with nothing there. So what exactly is going on here? Well, let's take a look at it together. So we're injecting into a query, and let's assume that the query is select star from users, where username is equal to admin. Let's say admin is what we input into our field. So originally, it's going to look something like this. But if it's not sanitized, what's going to happen is if the user puts in a single quote, this means that we've now escaped it, right? And we could do a lot with this. So because there's a single quote, we can then put something along the lines of and we can make it into a true clause. So if we do something along the lines of 1 equals 1. What this is going to do, and let's just assume that there is a single quote there as well. What this is going to do is it's going to result in a true factor. And whatever is going on within the query, it's always going to be set to true because something and true is always going to be true. Now that's if, let's say the username is admin. If we try to put username set to Evan, it's not going to work. It's not going to show anything. But because we know that the user exists on the database, it's going to always be true. Now, there's also something called the OR clause. The OR clause is going to be the exact same thing as the AND clause, except for it can be one of 2 things. Number 1, it could be the username is set to admin. That could be true, and the query will just execute. Or if 1 equals 1, it'll automatically go to the next step, next query, perform the function, whatever it's doing. So with AND, everything needs to be true. With OR, one of several things needs to be true. So looking at this, because this is set to false, because 1 does not equal 2, it's going to return nothing. And when 1 equals 1, it's going to return something. Just so we're clear on what goes on here. Now, we're going to want to try to retrieve data from this. And the first thing that I like to do is try to see if we can do something like sleep. And essentially what this function is going to do is this is going to make the server wait on the back end. And if it does work, we should see the response in 10 seconds. And it looks like no such function sleep. Okay. So whenever I see an error message, the first thing that comes to mind is just look it up on Google and see what comes up. So let's take on this no such function error and let's throw it into Google and let's see what some folks say. And it looks like it has something to do with SQLite. Just by doing something as basic as spawning an error message or using a function that maybe doesn't exist on the database, we can retrieve that the database server on the backend is going to be SQLite. So with that, we can start to do additional enumeration. Now, because we don't have access to the sleep function, this is not going to be a time-based attack. It could be, let's say, an error-based, but most likely it's not going to be. So we could try something like a union select clause. So we could do union select star, let's say from users, and then we'll just do something like that. And we'll click on send, and we receive this error message. So I don't really know exactly what this means. Selects to the left and right of union do not have the same number of result columns. So I'm assuming it has something to do with the star, if I'm not mistaken. But we need to figure out a way to retrieve all of the different tables. So let's head on back over here. And we'll do SQLite union-based query for tables in database, or something along those lines. And let's see what people come up with. Let's see if we can retrieve some information. Let's take a look at the Stack Overflow. And this person says SQLite does not support dynamic SQL, whatever. Okay, so this query will apparently get all the columns that are common in all tables in the database. So we could just copy this and we can see if maybe if this works. So we'll do union select, or maybe we don't even need that, but we could try to send it and it doesn't like the width. So maybe we could just remove that and see if that works. And it looks like it's just not accepting a lot of stuff. Okay, that's fine. So let's head back on over here, and the bulk of what we're going to try to do is let's see if we can just use this select statement. So it's just going to select the tables from the SQLite master. If you don't know much about SQLite, essentially the SQLite master is the main schema, quote unquote, for the database. And we're going to be retrieving the name column here. So let's head back on over to the Hacker Search application and just paste it in and send it on over. So it says that select is not allowed, but luckily for us, union select may be allowed. And it looks like we are getting an error with the table. And because, like I said originally, because we're trying to escape and properly complete the query, what we're going to want to do is remove the single quote at the very end. When we click on send, we can see that we retrieve 3 different tables from the database. We retrieve admin, we retrieve flags, and we retrieve users. So what exactly can we do with this information? Well, we know that we're trying to look for a flag. We could enumerate some of the columns. We'll have to figure out how we can enumerate some of the columns. I wonder if there's a way here. And it looks like this person does have something. So maybe we can try to use this and see if it works. I'm not really sure if it'll work or not, but we could try it. So let's head back on over here. Let's modify this a little bit. So we're going to set tables to flags, and then I guess we'll just leave that to T, and I hope this works. And it doesn't look like it is. Or is it? Let's see. No such column, PTI name. Okay. What if we just put name? No T name. Okay. What about something like name? Like that. Okay. We retrieved the admin, but we want to retrieve all the columns. We don't want to retrieve just what we specified. Okay, so let's go back to our original query. Let's see what we could work with. So we know that union select works, so we could do just the basic and see if this works. So we could do flags, since that's the table that we know was working before, and we still retrieve this error message. So because we're looking for a flag, most of the time on CTFs, all you got to do is type in flag and see if maybe that is the column, which it is. So flag SQLi API bypass complete. So we'll take the flag and we'll paste it into the dashboard, and that's the first challenge done. The second challenge is break the gate, which is 100 points, and it's essentially the exact same thing, except unfortunately for them, this API trusts user input way too much, and the mission is we're going to try to get SQL injections to, I guess, hijack the admin session. So let's head on over to break the gate, and we see what we're working with. So we're going to do some basic stuff like admin, and we see that we get an error message, invalid credentials. So when this happens, what you're going to want to do, and remember originally when I said something along the lines of and or clauses, this is the kind of case where we're going to try to do that. So let's see if we could do something like and 1 equals 1, and let's send it. And it looks like it still says invalid credentials. So let's try to copy this on over, log in, and still nothing there. So what we could try to do instead is maybe it needs to be an error message, so we could just change it to 2, and still nothing there. So maybe the credentials are invalid, right? And let's go back to our query that we specified before. So select star from users where username equals admin, and let's just say it's also doing and password is set to admin as well. So again, we have our input set to admin, and what we're trying to do is we're trying to escape, which is what this is doing right here, right? So this is the original single quote, and this is our injected payload right here. So we could try to do the or clause, because let's say this fails and this fails, or 1 equals 1, which is true. That should result in a true factor. So we could head on over here. We can move this to or clauses, and we can click on login, and we see welcome Alice. Well, this is a bit weird because we're trying to log in as the admin, but we're getting a different user response and information. Doesn't really make much sense. So we could try to do, let's say, one incorrect and one correct. So let's say that the username is invalid. So we'll just set it to 2. And then this would be a valid response because it said something about no password required or something along those lines. So maybe we need this to be true and this to be false. When we click login, it doesn't work. So maybe both of them need to be not true. And when we do that, we retrieve the flag. So flag, who needs passwords when you have SQLi? And we get welcomed as the admin. So we can go back to our dashboard and submit the flag. So that's all for section 2. I hope you did enjoy. The SQL injection vulnerability is one of the most impactful vulnerabilities you can find on an application. Not only is it impactful in the sense that you can retrieve a lot of information from the database, but also you can potentially obtain RCE depending on what configuration the application does have. If it's a Microsoft SQL server, there's a high probability that it's probably misconfigured to where you're using the admin credentials on the database. And with that, you can use something called XP command shell, which I'm going to be going into in a later video. In this episode, we'll be taking a look at slash and dash, and there are 3 challenges. So let's jump right into it. Roads less traveled. And it says, ever feel like the web is hiding secrets just beneath the surface? You're right. This challenge drops you into a janky search API with a serious trust issue. It happily believes whatever path you feed it. Your objective, go off the beaten path, dodge the digital bouncers, and unearth the legendary flag.txt lurking in the private spot, the root file system. Pro tip, sometimes the way forward is actually up and back. And we have the roads less traveled link. So we'll head on over here and we'll take a look. We could see that it already gives us the URL that we have to work with, and there's a file parameter, which if you know anything about file parameters, you know it's probably a directory traversal attack. So we could go here and we can try to head on over to the API, and just to make sure that everything is working properly, we can just go to welcome.txt. And we could see welcome to the Hacker Access Terminal. All right, awesome. So we could try some basic stuff when it comes to LFI or directory traversal attacks. Try to say that 3 times fast, which is just doing a basic .. And with Linux file system, when you do a .. it's going to take you to the directory above you. So if we go over to my terminal right now, to my desktop, for instance, so let's go to desktop, and just to make things a little bit easier to explain, we'll do API 2025. So right here, when we do a cd .. we're going to be taken back to the desktop, which is essentially what we're doing. So depending on where the file server is, we could just do a .. and then we could do a private because they told us something about it being on the private directory, as well as the flag.txt. When we click enter, we see that we do retrieve the first flag. So we'll take this and we will paste it into our flag. We'll go over to the second one, which is filtered fun. It looks like it's the exact same thing. Step into the shadows of web with this entry-level exploit challenge from the underground. Our shady search API has a tiny flaw, and you're just the right mischief maker to exploit it. Your mission, break out of the sandbox, sidestep the guards, and sneak peek at the flag. Okay, so let's head back on over here, and it looks like it's the exact same thing. So we'll go here, and again, we'll just do welcome.txt to ensure that it works, and it looks like this is a different application, so secure API. We could try to do the same thing, so we'll just do a .. private/flag.txt, and we can see that we actually get an error message, no such file or directory, and we see that there is a few things. Number one is we now see that there is a /app directory, which wasn't there before. We didn't get that error message before. So knowing this, we may be able to retrieve the source code of this challenge. So if we try to do another .. let's see if we move up a directory, and it looks like we don't. So something's going on in the back end preventing us from using ... We could try to go to the /API because it's right there. And we could try to do something along the lines of, let's just do app.py, because that's generally what these CTFs are. It's either app.py, main.py, server.py, something along those lines. When we click enter, we could see that we retrieve a bunch of information, and it looks like to be a Flask application. And there's a few things here. Number one is there is the unintended way of doing it. Now, when I did this originally, all I had to do in the file parameter was /flag.txt, and I got it across the board through all 3 challenges. They since fixed that, but if you go to the source code, you can actually see the flag is right here. Filter bypass ... Not going to really worry too much about the flag. We want to do it the intended way. So looking at the source code down here, though, we could see that this filter is intentionally flawed to allow the challenge solution, and its file name is equal to filename.replace ... with nothing. So what that means is every time we do a ... it automatically strips it, and we need to find a way to bypass it. And one of the most common ways to go about bypassing a filter like this is using 4 dots and 2 slashes. And here's what's happening. Every time you do this, you see that there's 2, let me make this a little bit bigger for you. So let's say we have HTTPS, let's just call it google.com, and we'll do /API/read file equals ... // Right here is our quote unquote ... And what the application is going to do is it's going to remove this, but we still keep the ... because we put 4 and 2. So with that, all we have to do is add 4 dots and 2 slashes and then put our file, which let's say it's private/flag.txt. So when we do that, we should retrieve the flag. And let's see if that happens. And it looks like it does. And we do retrieve the flag right on cue. So flag, filter bypass ... and we will paste it into this challenge. The final challenge of this section says the file system holds secrets, but this time the path to truth is scrambled. You found a quirky search API that's a little too trusting and a little too encoded for its own good. Your objective: decode the madness, navigate through the layers of obfuscation, and uncover the private flag.txt hidden in the root. Okay, so let's head back on over to the URL. And again, exact same endpoint. So we're going to do /API/read, and we're going to do the file is welcome.txt, and we can see encoded access. First thing that comes to mind when they say encoded is double URL encoding, which is another common directory traversal attack vector that you can do to bypass filter. But we could try to do, again, just the basic flag.txt, and we can see that invalid file name directory traversal is detected. So that's not going to work. But originally, what we could try to do instead is we can go back to that app.app.py, because I'm sure that it's probably in the same location as before. And again, we could see the unintended path, which is the flag right here. But again, we're not going to use that. We're going to try to do this for real. So looking through some of the source code, let's just see if there's anything that's of interest, which, to be honest, what we're going to do actually is we're going to go over here and we're going to beautify this just a little bit. So we could see here that what's happening is first to decode the obvious traversal, that's fine. And it looks like check for directory traversal attempts the first layer decode string, only block unencoded or single encoded traversal attempts. This allows double encoding traversal to work the intended solution. So they're basically telling us within the app.py what we have to do. So we'll come on over here, we'll go to repeater, and we'll modify this to be a ... private flag.txt. And here we'll actually just quickly go over to decoder, and we will encode this to the URL, and we'll encode it again to URL, getting this huge string. Come back over to repeater, and we'll paste it in and submit it. And we can see that we retrieve the flag. So double encoded traversal master. Head back on over to the challenge and submit the flag. And that's the end for section 3. I hope you did enjoy. If you did, please be sure to leave a like and comment down below what you thought of this episode. If you do have trouble with the challenge, please feel free to let me know. This was a lot of fun. I've only found a few directory traversal attacks on real-world engagements, so seeing a challenge like this is always a motivational boost just because you don't really see it that often, so it's good to always brush up on your skills. In this section, we'll be taking a look at Bug Bounty Hub. There are 3 challenges. And the first challenge says, Bug Bounty Hub is a new platform where security researchers can report vulnerabilities. The platform looks polished, but sometimes appearances can be deceiving. Can you find a way to extract hidden information from the system? And we do have a URL here, so let's head on over to this URL. And we can see that we have a login and registration page, so we can quickly register, and we could just try, let's say, admin@mresecurity.com. We'll do our username, so that's mresecurity1, and then test 1, 2, 3, bang. So it looks like email's already registered because I did record this before. So we'll just do something like testing@mresecurity.com. And again, we'll just do mresecurity1 as well as test 1, 2, 3, bang. So after registering, we have a few buttons here. We have the view my reports, report templates, and submit new report. So let's head on over to report templates, since that seems to be the biggest thing here, right? Whenever you see something related to templates, the first thing that should come to mind is server-side template injection. So looking at this web page, we can see that there is template syntax, and templates use a simple syntax to display reports. And underneath it, it says, for advanced users, we use Ginger 2 templates. So just by this information, it's safe to say we most likely have a server-side template injection. And essentially what that does is whenever a developer, let's say they're using Flask on the back end, they'll use Ginger 2 as their primary to show data within the web page. And you can use these squiggly brackets to figure out different kinds of variables, and it'll display the values onto the web page, right? So if we do report.title, and let's just quickly create a new template to showcase this. So we'll just do something like test, and we'll keep report.title, and we'll save it. So we have to come over here, and we'll just put the title as something like, this is a test, testing 1, 2, 3. So when we submit the report and we go back, oh, here we go, preview. So here we see that it now says this is a test with the low severity, and then testing 1, 2, 3. So right here and right here, it looks to be that they are using some form of variable, which we just saw when creating the template. As you can see right here, we do get the report.title and report.description. Now, if you've never done server-side template injection, there is a fantastic platform called Payload All the Things. So if you look up SSTI Payload All the Things Ginger 2, you can go over to the GitHub page, and they have a bunch of different things, but because that Ginger 2 is based around Python, we're going to stick to Python. All you gotta do is click on the Python, and we see that we have a ton of stuff. This is not a Django application because they told us that it's Ginger 2, so let's stick to Ginger 2. We can verify that there is a basic injection just by doing something along the lines of this. So we'll copy the 7x7 payload, and we will paste it in to everything. And we'll just click save. We could see that this does not get executed, but when we go over here, we do see that there are 7 sevens on the board, indicating that there's most likely going to be server-side template injection. So heading back on over to the GitHub, we can take a look at some additional things, and something that I like to do is try to find an RCE payload. So we can try a few of them. We'll try this one first just to see if it works. So we'll go back over to templates. We'll create a new template, and we'll just name it something random. We'll paste this in, and we'll just do ID. And what this is going to do is it is going to run the OS module through Python and then execute the ID and read the output. So when we click save, we can preview it, and we can see that we are root on the file system, which is great to know because now we have RCE. We know that we have RCE. So now we can go back and we can start to play with some of the functionality. So the first thing that you would normally do is try to get a reverse shell, but we're not going to start doing that because it's a little bit frustrating to do, especially when you don't have a VPS. I did do a video about how to get a free VPS, but we're not going to really go into that today. Instead, what we're going to do instead is we're going to do just an ls tech la. And essentially what this is going to do is it's going to list all the folders, all the files, and all the hidden files or directories within our current location. So we can click on save and we can click preview, and we can see that we do get a few things. The first is app.py. Second is flags as a directory, as we can see by the D here, as well as a couple of other things like the static, as well as the templates and the requirements.txt. But what we're going to mainly be focusing on here is the app.py as well as the flags within the directory. So we'll come back over here. Again, we'll just say get flags and we can paste this in. So we could do something along the lines of, let's say, do an ls tech la, and then we could just say flags. Since it is a directory, it'll go to that directory and then showcase the flags or whatever is within it. And it looks like there are .txt files with all the different kinds of flags. So going back, we could do something pretty basic, and we'll just say got flags as the name, and we'll change this to cat flags / flag1.txt, and we'll paste this in 2 more times. So that's flag 1, that's flag 2, that's flag 3. Save it and preview it, and we now retrieve all 3 flags for this challenge. Now, I kind of skipped ahead because, to be honest, this is the unintended way of doing things. This is also the only way that I found to do stuff. I'm sure there's another way because it says here stack trace reveal secrets. So I'm assuming that we have to produce an error somehow within the application. But if there's an unintended pathway, most of the time I take that and I run with it, just because the developer didn't put in proper security measures for me to not do that. So we'll come back over to here and we will paste it into our dashboard. So there's the first challenge. Here's the second challenge. And here is the third challenge completed. Awesome. This challenge is named Massive, and it says the challenge presents an enterprise-grade user management portal. The developers have implemented a profile update feature, but they might not be properly validating user input. Your goal is to find a way to escalate your privileges to admin and access the admin dashboard. And we have a URL here. So let's access it, and we can see that we, again, in all of our previous challenges, have a login page as well as a registration page. So we can come over here and let's just do MRE Security. We'll do testing at mresecurity.com as well as test123bang. So we are now registered. Oh, and it looks like our user was already created, but it also just showed what is going on here. So was it created or was it not? We're getting 2 different outputs. So let's try to do MRE Security 1, and then we'll do test 123bang. We can see login successful. So I guess it worked. I don't know what the error message was. So we can first start off by just checking the source code, because this is what I normally do for most of the challenges here. And looking at the bottom, we see that there is a script.js and a debug.js. So let's head on over to the debug.js and let's see what's going on here. So it looks like there is just one endpoint within this section, and it looks like just the registration. So API auth register with the post, which is what we just did. So not going to worry too much about that, but let's head on over to the script.js and see what we're working with. We could see that there is a little more information. It seems like there's stuff having to do with the admin panel, which they were talking about in the original prompt. Looking at it, we have the login page, which is post. We see that there's also an update profile section, which is, again, in the prompt is what they were talking about. We have a fetch, and then we have API profiles me, and there's a put, and you can insert specific information in the body, and then it'll send back a response. Let's see what else is within this. So there is also the admin page. So how to access the admin page, you have to go to API admin dashboard. And I guess this is where the flag would be shown. So knowing this information, we could probably get started with it. So let's head on over here. And when we log in, nothing happens. We're not within a dashboard. We don't get redirected. So most likely what's happening is we have to use that API that we just saw. So API slash, I think it's what, profiles slash me, or API users me. It could be one or the other, not entirely sure. So we could try to do, I'm assuming it's going to be API profiles me because it has the put method here. So let's head on over here. So we'll copy this, go into Burp Suite, and let's make this bigger. All right, so now that it's bigger, we can head on over to the repeater, and we can modify this to say API profiles me. And a neat trick that you can do within a request is you can right click here and you can say change request method. It'll say post. We'll have to change this to put because we did see that within the application. So we can put inside of here, I guess, something completely random. Let's see what we're allowed to put in. So we could put in display name, and let's see what happens. So we'll change our display name to, let's say, please sub, and we'll send it off. So we could see that the display name shows up like this, which does look a little bit weird. I don't really know. Oh, it's because this content type, it's not supposed to be application form URL encoded. It's supposed to be application JSON because we are working with an API. So sending this off, we could see that it's still doing that, but we do see that the display name has since changed, which is very good. And there's also a role here. Now, in the prompt, it was telling us, hey, make sure to change your role to admin. We need a privilege escalation vulnerability. Because this is a put method and we're updating the profile, I'm assuming what we could do is just do role and then modify this to say admin. So when we send it, it says role is admin, which means that we are good to go on this front. We should probably also change my display name back to Emory Security 1. So let's just do display name, and then we'll say Emory Security 1. So send that over, and we're good to go there. So going back to the application, we can just log in again and see if maybe we retrieve the flag. So we could do Emory Security 1, and then we could try to do test 1, 2, 3, bang. Let's log in, and it's still not showing anything. So what we could try to do is, let's see if we now go from the login page, we have the API user me, and this looks to be the cookie that we're working with. So we can go over to the repeater and we could do API admin and then dashboard, because again, we saw that within the JavaScript in the web page. So clicking on send, we see that something has gone wrong, and it, for some reason, that duplicated. I don't know why, but when we send this on over, we can see that we retrieve the flag. So flag protected fields bypassed. So let's copy this on over and let's paste it into the dashboard. And that's all for this challenge. Super easy and sweet to do. The mass assignment vulnerability is definitely one of the scarier vulnerabilities, and you do find it often within applications. A lot of the time, developers forget about access controls and they let users do whatever they want, such as privilege escalate. So making sure that this doesn't happen is always beneficial, right? Because you don't want users to become admin. Just know that whenever you're looking for, let's say, something having to do with API security, make sure to check out this vulnerability. Whenever you're on a update profile, always insert role admin or role, whatever the role may be. It may not be called role, it may be called something else like privilege or group, but there are rare cases where you do see privilege escalation and it turns into a critical vulnerability, which you can get a very nice payout for if you're on bug bounty hunting, or the client will be really happy if you do consulting. In this section, we have two challenges on permission slip. The first one is molehill. And it says a company has exposed their API documentation through an OpenAI specification. Most endpoints require authentication, but there might be a misconfiguration where an endpoint that should require authentication doesn't actually enforce it. Your task is to analyze the OpenAI specification, find the endpoint that doesn't properly enforce authentication, and extract the flag from the vulnerable endpoint. Okay, so we see here that there is a web page with a few different things. The first is that we can download the OpenAI file. And the second is there is also documentation. So we can head on over to the Swagger UI and we see that there is a bunch of endpoints. Not a whole lot, but there are quite a few. And we're going to try to use something called APISEC scanner. And if you don't have never used the APISEC scanner, essentially what it is, it's a API scanner that finds vulnerabilities within your API. So going back, we could download the OpenAI specification and we get an OpenAI.json file. We could head over to this page, and if you haven't signed up, just go to APISec.ai, register completely free of charge. It's a freemium application. And once you see this page, you know you're good to go. So click on register your application now and you'll see a pop-up. Click on the OpenAI spec. We can click next and then we can upload a file here. So in our case, it's just going to be the file that we just downloaded and we'll name it to Molehill. So we'll click on continue and it looks like that's okay. So we'll click on onboard and we'll see if maybe it finds anything. It probably won't because it's saying localhost 3000. We don't have localhost, so we may have to do something else, but we're going to see if this works or not. So looking at it, we could see that there is a critical here. And if we read it, is there anything in here that showcases? Doesn't look like it. Okay, so maybe that's not it. Let's see if there is anything here. Authenticated, looks like there's 20 authenticated. How do we see whether or not it is an unauthenticated endpoint though? Let's click on access and it looks like they are all authenticated, which is obviously not true. One of these endpoints is supposed to be unauthenticated as shown in the prompt. So maybe we have to do something else. Let's head back on over to APISec and let's modify the application configuration a little bit. Is there a way to modify this? And we'll do https:// and we'll just paste in this URL here. So we'll paste in this, test if it's reachable, and it should be because we just accessed it. So let's hope that it does find it and it works. And it looks like it did. So now what we could do is we could try to see if it finds anything of interest. So we could do a scan all endpoints and initiate scan. And this may take a few seconds, so let's wait it out and see what happens. Coming back over here, we could just see if maybe it's found something, and it looks like it has. And it says unenforced credentials for this endpoint. And when we review it, it says that the request body, there is nothing in the request body. But looking over at the response, this endpoint doesn't require authentication. So let's see if we have to, let's just go to this endpoint and let's see if maybe it'll find it this way instead. And there we go. Okay, so we had to go to the endpoint itself. I wonder why it did. Oh, you have to click the arrow down. Here it is. Okay, flag, OpenAI vulnerability intro. So we'll copy this on over and we'll paste it into our challenge. There's the first flag done. Let's move over to Mountain, which is 200 points, and it says essentially the exact same thing. And over here, it does say use the APISec scanner to assist you, which we're currently doing already. So again, we'll download it. So now that we have, and we downloaded the OpenAI spec, we can again come back over to our APISec scanner. And we're going to, instead of doing this application, what we need to do now is we need to add an application. We're going to add OpenAI specs and we are going to paste it again in to our scanner. So we'll call this one Mountain. We'll click continue. We'll modify this to be the URL that we had, which is over here. So we'll take that and we'll paste it on in. and we'll click on onboard, and it's going to do some basic scanning. Like I said, it'll initiate the first scan just to see what it has in relation to what endpoints are currently being accessed within the API. And once it's done, we can begin the scan. And it looks like there are 1,000 endpoints. Let's see if it did find anything on that initial one. It looks like it didn't. So what we could do is we can start scanning all of these different endpoints. Now, this may take a second, so I'm going to cut and be right back when it finishes. All right, and after a while, this took quite some time, but we could see that there is a vulnerability and unenforced credentials with this endpoint here. When we click on it and we scroll down, we could see that there is the flag open API spec vulnerability as the flag. So we'll come here, we'll copy it, and we'll paste it on into the flag. And that's all for this episode. Be sure to check out the APISEC scanner. And if you want to see a demo, please let me know by DMing me either on LinkedIn or reaching out via Discord. And that's all for this episode. I hope you did enjoy. And if you do want to use the APISEC scanner, again, it's completely free. So you can just go on and check it out. So today we're going to be talking a little bit about rate limiting. And if you don't know what rate limiting is, it's essentially allowing you to brute force or identify specific IDOR vulnerabilities within an application. For instance, if you don't have proper rate limiting on, let's say, a login page, you can potentially brute force the password of a username and then obtain access to that website of that user. So rate limiting is extremely important inside of web application security because you can also DOS people or denial of service their systems. So we're going to go through a couple of challenges on the API Security University's 2025 CTF. So it says, welcome to the world's most vulnerable password vault. No rate limiting in sight. This challenge presents a simple password vault protected by a 4-digit PIN. The catch, the developers forgot to implement any rate limiting whatsoever, making it the perfect target for a brute force attack. Your mission is to write a script to systematically try all possible pins until you find the correct one. Then access the vault to retrieve the flag. Can you automate your way through 10,000 possibilities to crack the code? And here we have the website. So it says super secure password vault and with the visitor ID, as well as you can input 4-digit PIN, verify PIN, access vault, or also get a hint. So we could just try something pretty quick here. We could just try to, let's say, do 1, 2, 3, 4, click verify PIN. So it says incorrect PIN. Now, there are 2 ways to go about doing this challenge. So I'm going to quickly go through both. The first is you can use Burp Suite Intruder to brute force the PIN that way. So if you head on over to Burp Suite, you can go to intercept, verify PIN. You'll receive this API verify post request with the PIN attached as JSON. You can send it on over to Intruder. And from here, you're going to want to put the SS symbol, I don't really know what this is called, and click add. So now you have both of them sandwiching the PIN. Next, go to the payload type and select numbers. You'll want to do 1 through 10,000. And also, you're going to want to do a minimum digit of 4. And what this is going to do is this is going to put 0001, 0002, instead of just going 1, 2, 3, 4, 5, 6, because I'm assuming since it's 4 digits, you're going to need to put in a 4-digit PIN. If we try to just put in 1 digit and click on verify, it says you must have a 4-digit PIN. So that's what that's going to be doing. So minimum integer digits, set it to 4. Make sure that the S's are in between both the quotes, so that way it hits the PIN. And then you can just click start attack. And I do not have the Pro Edition on my Kali, but as you can see, the payload is 0001, 0002, and it's just going to go down and do its thing. Now, this is definitely a slow way of doing it. So unless you have Pro, I would not recommend you doing it this way, but you can also use a Python script. So here I've created a very basic Python script and we're going to go through it together. So you just grab the URL and you create a session within the request module of Python. And then for this case, I don't want to brute force all 10,000, but if you wanted to, you could just put this line for I in range 10,000. And that's going to go about brute forcing 1 through 9999. In our case, I already know the PIN and I don't want to waste too much time. So we're just going to have it from 9100 to 9200. The number again is going to be set to 4 digits. So instead of it being 1, 2, 3, 4, 5, 6, it's going to be 0001, 002, and so on and so forth. Neat little trick in Python if you didn't know about to definitely check out, and it's extremely useful if you do have something like this on a real world application. After that, we're going to set our data points for the request. So pin, and we're going to use the F for format and then set it to this variable number, because this is going to hold the loop number that we get. Next, we're going to send a post request over to the API verify endpoint that we just saw, and then supply it with the JSON data of pin. From there, we're going to have to sleep for just a couple seconds because there's minimum resources on this box. So I don't want it to crash and die and mess with our script. We're going to print out the text, whether or not it's an error or if it's accurate, and then we'll be able to retrieve the flag that way. And if it does return anything but a 401, it's going to print out the pin and then just exit out the program, indicating that the script has worked and it is done. So what we could do now is we could just type in Python 3 and we'll just do challenge1.py. And as you can see, it starts to say success and then incorrect pin. And after a couple of seconds, you can see that we do retrieve the correct pin. So 9136, and it says true, pin verified successfully. We can head back on over to just to confirm on the website. Let's see if that does work or not. Let me just make sure that Burp Suite is still not active, and it looks like it is. So we'll just quickly drop all those requests and do it again. And we can see here that the pin was verified successfully, and now we can go about accessing the vault and retrieve the flag. So the next challenge that we're going to look at is the rate limited challenge, and it says, think you're clever with your brute force attacks. We've added rate limiting to our vault. This challenge presents a password vault protected by a 4-digit pin, but this time with IP-based rate limiting to prevent brute force attacks. Your mission is to analyze the rate limiting mechanism, identify its weaknesses, and bypass it to access the vault and retrieve the flag. So let's head on over to this URL and we see what we have to work with. And it says here, enter your 4-digit PIN to access your stored password. For security reasons, PIN attempts are rate limited. And it says that the service implements a rate limiting to protect against brute force attacks. The maximum of 3 incorrect PIN attempts allowed per minute. After the reached limit, you have to wait 60 seconds before trying again. So this is a decent rate limit, but also 60 seconds is not really a lot of time. So we could just try to do 1, 2, 3, 4. We could see that it says incorrect PIN. And before I lock myself out, what we're going to do instead is we're going to go to Burp Suite and intercept this pin to see what we're working with. So we will go to here and click on repeater. And as you can see, there are a couple of headers here. So it says that the rate limiting limit is 5, that the rate limiting remaining is 3, and the reset time is, it looks like it's probably 600 seconds. What we could do is we could just try to see how the rate limiting works. So after each attempt, you see that it does go down. And after a while, you can see that it hits 0. And the next attempt says too many attempts, please try again later. And then we have to wait for this time to expire. There's a very easy bypass to go about rate limiting that a lot of people do know. And this is something that I actually found on an engagement recently, which was if you go to your headers and you type in X forwarded 4, and then you could put in any sort of IP address. So you could put in localhost, you can put in 1111, you could put in 2222. It doesn't really matter what's in here. As long as you have an IP address that it can quote unquote forward to, that's all that you need to do. So in this case, we'll just put something like 12, 12, 14, 10, for instance. It's not a real IP address. Nothing's actually happening or going on. But when we click on send, we could see that we do get incorrect PIN. But remember, we still have a limit even with this IP address. So we're going to have to figure out a way to iterate over each IP address to retrieve the flag. So we'll head on over to VS Code, and I created this script here that I'm going to walk through quick. And essentially all it's doing is it's creating a session through the request module. It's looping through 100 different digits. We're going to grab the number again based on the 4-digit model, not the 1-digit model. So we're going to have 0001 instead of just 1. Then we're going to do the PIN, which is going to be the data point that we're going to use for the post request. We're going to do headers now, but this time we're going to put in X forwarded 4 and we're going to add the IP address as well as the number, which means we're really going to have unlimited numbers because this is going to loop through every single time and generate a new IP address, meaning that we essentially bypass the rate limiting mechanism. This is the exact same as the last challenge. Is we go to the API verify, we store the JSON, and then we also store the headers. If it's accurate, we're going to get a correct pin as well as the flag within the response. So, or hopefully the flag in the response. Some of them have this and some of them do have the flag in the response. So we'll see if this is one of them. So we'll head on over to challenge 2 and we'll just let that run for a second. And as we can see, after a few attempts, we do retrieve the correct pin. So we can head on over here and we can paste it on into the enter pin field. Click on access vault and see if we do retrieve the pin and the flag, but it looks like, again, we do have to get rid of that. And we can see the passwords as well as the flag is here. So flag X forwarded for bypass. So we'll copy it and paste it on into the challenges. So the next one is called rate advanced, and it's going to do the exact same thing, except this time it's going to be a token-based rate limiting. So we'll just head on over to the URL and we see what we have to work with. So we can see here that says that it's an advanced password management with enterprise grade security and sophisticated rate limiting protections. It's IP-based rate limiting, progressive timeout periods, and a backoff algorithm. We also have an attempts counter here, so we have 5, and we can just see what happens. We can click on verify pin, and it says incorrect pin. Let's just try to do Burp Suite again to see what we have. So we'll send it off to repeater, click on the post, and we can see that it says invalid or missing session token. It looks like we need a token first. So we need to find out where this endpoint is. And the first thing that I like to do is always check the source of an application, because maybe they do give off something that we don't see in the front end. I don't believe it would be in here, if I'm not mistaken. So we'll just type in session, and it doesn't look like it's in there either. So in order to find this endpoint, we're going to need to do a little bit of manual enumeration on the box. And throughout the CTF, everyone was getting stuck on where this session was. But if you pick out keywords, it's a fairly easy challenge to do. So we're just going to head on over to Burp Suite and we'll go to repeater. And because that we know that it's probably named a session, we can assume that's either going to be /API/session or /API/token. So we'll just do API session and we'll click on send. And we can see here that we do have success is true with the generated session here. And we can use this token by going back to our verify command or verify endpoint. And we can just type in X session token and then paste in this token. When we click on send, we can see that now we do have the session working, and we also get rate limited after 5 attempts. So as we click on through, we can see that it has too many sessions and we need to refresh our sessions or just wait for this to expire. But this is a long time. 900 seconds is a long time to do rate limiting. We don't want to do that. We need to figure out a way to bypass this. So what we could do is we can go to the script that I've created and we'll take a look at what exactly it's doing. So what this script is going to do is it's going to create a session in the request module, again in Python, and then it's going to send a post request over to the API session, grab the token from the JSON. We're going to do a loop over 3400 to 3500. We're going to set the X session token header in the request and then send off the post request. And again, if we do get the correct pin, it's going to show us here as well as the r.txt to hopefully retrieve the flag. So we're going to do Python 3 chal3.py, and we're going to let this run quickly and see if we get the flag. So after a few seconds, we can see that we do retrieve the flag token refresh bypass master, and the correct pin is 3456. Something that I want to note, which I thought was pretty interesting, is I did not have to continuously reset the sessions in this script. It kind of just worked, and I'm not really sure why, but the headers worked, and I didn't need to continuously send post request over to the session API endpoint. It just worked with one session token. So it's a little bit weird. I don't really know why that works, because in Burp Suite, like I said before, it said that the session has expired. So I really don't know what's going on or how it's working, but nonetheless, we did get it. and we can copy it and paste it into the challenges. Last but not least, we have rate quantum, and it's going to be a quantum inspired distributed rate limiting system. So we'll just head on over to the endpoint and we'll take a look at what we have. So we can see that we do have a quantum vault and there is an enter pin. So we'll just put in 1, 2, 3, 4, click on verify, and we can see that we do only have two attempts remaining. So we're going to need to learn a little bit more about this application. So let's head on over to Burp Suite and go to the proxy HTTP history, and we'll see what we have to work with. So the first thing is that we do get a quantum session, and this looks to be just a JWT with, I guess, an IP address, a node ID, as well as various other things. Then we can go over to here and it says tokens remaining is 8. So we're going to be limited on the tokens that we can generate. And it also expires in 30 minutes. We can click on inspect token and we could just see whether or not it's still active. So in this case, this one has 0 attempts and it's on node ID of 0. When you click on quantum verify, we do have the incorrect pin. So this is how we're getting the pin. And then we are also setting the node ID as well as the attempts remaining. So we also see here that there is a rotate token. And when we click on that, it looks like it just rotates out the token to something new. So when we head on over to here, click on rotate token, we can see that it says the quantum token has been rotated successfully with, again, another JWT that's completely different from the one that we just had, as well as it does expire in 30 minutes. So already we know that we don't have to get the quantum session. We can only get that once. And then we could just continuously rotate that token with our quantum token here. So let me just make this a little bit bigger. So this doesn't seem too challenging at first, right? Theoretically, it doesn't sound too challenging. All we have to do is continuously rotate the tokens. And then we need to just come over here to quantum verify, and then just supply the pin. So let's head over to the VS Code and let's take a look at the script that I've created. And so here we're again doing a session, and then we're going to send a post request to get the initial quantum session. We're going to print it out just to make sure that we got it correctly. We'll get the JSON with the token, and then we'll do the range again, which is 6550 by 6950. We'll do numbers, so 0001 all the way down to whatever it could be. And then we'll do data is the pin. We'll do an X quantum token, which we could see right here in Burp Suite. We could do the X quantum token as the current token because we're currently getting the current token, which is the initial session. And then from there, we're going to go about rotating that token once, getting the token again from the rotate token. And then we're going to verify to see whether or not the pin is accurate. And if it's not, it's going to continue to loop and get a brand new token from the rotate token. It's going to verify it and continue on that loop. So we're just going to do Python 3 chow4.py. And as we can see, we do obtain the pin, which is 6907. So we can copy this and go here. We can just click verify and we see that we do retrieve the flag quantum token forgery master. Rate limiting is a very important mechanism to have on web applications. There are a couple mechanisms that I can think off the top of my head, but for the most part, it's not foolproof, right? You can have a WAF or a web application firewall in place, but even those get bypassed. I just recently bypassed Cloudflare through various means on a application I just recently did. And it bypassed the rate limiting mechanism. Even a WAF won't save you. So you need your own custom implementation on your web application to properly manage rate limiting and brute force attacks on applications. But this CTF was a ton of fun. And if you missed the CTF, there's going to be more down the line with API security. So be sure to check them out in the description down below. They do have their new APISEC 2025 Back to School edition. Whatever it is, it'll be down in the description below so you can register. Check it out. Got some great talks going on, and I'm looking forward to the next CTF. So big shout out to Maltech Solutions for putting this together and having me do my final video. They ended up shutting down the environment, but they kept it up for me for only a couple more days so I can get this video out to you guys. If you did enjoy it, please let me know in the comment section down below, and please like, subscribe, and I'll see you in the next one. Take care.